Hello everyone, welcome to IIT's GATE classes. So in today's video session, we are going to see the GATE 2023 solution of computer science and information technology of the subject digital logic. So the number of questions that was asked in your 2023 from digital logic. So 1 mark question, there were 2 questions, and 2 marks question, the number of questions were 2. In total, there were 6 questions, 6 marks question. So let us see all those questions one by one. So before starting this video, I would like to tell you that if you haven't subscribed to our channel for more such video, kindly do subscribe to our channel. And if you like this video, please like and share the video with your friends. So the first question that was asked, it was a very simple question. So the question asked is the output of a 2-input multiplexer is connected back to one of its input as shown in the figure. Match the functional equivalence of this circuit to one of the following options. So this is your circuit. This is your 2 cross 1 mux, 2 input, 1 selection line. So which of the following out of the option is this circuit equivalent to? We have to check. So we know that if I want to write the output over here, so let me solve this question over here. If I take it as Q plus, okay, so Q plus will be equal to what? So this is Q, let this input be I0 and this input be I1. So Q plus will be equal to S complement I0 plus Si1. Now S, if it is your 0, I0 will be selected. If S equal to 1, then this input, okay, let this be any input. Let me write it as input. So I1 will be selected. So now if I put the values of Q0, sorry, I0 and I1, what I can see that this is actually S complement I0 is your Q, okay, plus S dot I1. I1 will be whatever state you give, so that it will be, so Q. So now if I solve this, you can see Q plus is equal to, if I take S, sorry, Q common, so this will be S complement plus S. Now you might be thinking that this is your floating input, but it's not. Whatever input you give, when S is equal to 1, it will be directly transmitted to your output, okay. So this Q plus comes out to be Q. So now you can see this is kind of D. Okay. Now D means what? Delay. Now I am not saying that whether it is a flip flop or latch. Now which option do you think? D flip flop or D latch? So we know that flip flops are basically what? It is edge triggers. Edge trigger. So it can be negative edge trigger or positive edge trigger, and latches are usually your level triggering. So here you can see if this S momentarily, if I give 0 or 1, this multiplexer inputs will not be getting selected. For getting the input lines to be selected, what we should have a positive level or a negative level, or you can say 0. So for that, basically what we have, this is your equivalent to D latch, because here we will have level triggers. Okay. So the correct answer for this question is what? D latch, not D flip flop. So next question is a very simple question. A particular number is written as 132 in radix 4 representation, the same number in radix 5 representation. So we have a number 132 radix 4. We have to find what will be the equivalent number in radix 5. So for such kind of question where we have to find your one from, when we have to convert from one radix to another, what we do, we basically convert this number to your base 10, and then we will convert this base 10 number to our desired radix number. So first let us convert this number to your base 10 number. So if I want to do that, 132 base 4, I can write it as, so this power will be, so this 2 will have power 4 to the power 0, this will have 4 to the power 1, and this will have 4 to the power 2. So I will write this as 1 into 4 square plus 3 into 4 to the power 1 plus 2 into 4 to the power 0. So this will be 16 plus 12 plus 2. So 16, 12, 28, 30. So this will be 30. So this is base 10 number. Now we know base 10 number, how do we convert it to any R radix number? Simply by dividing, continuous dividing. So 30, if I continuously divide it by 5, so 5, 6, 30. So this will be 0. You can see this number is still greater than 5. So once again we need to divide this. So 5 ones are 5, remainder will be 1. So this point it will be your MSB and this will be your LSB. So this will be what? So this 30 represented in base 5, it will be 110. Okay. So now 132 base 4 is actually equal to 110 in base 5. So the answer here will be 110. So the next question is a very good question. What it is? Consider a sequential circuit consisting of T flip-flop and D flip-flop as shown in the figure. So these two are T flip-flop, toggle flip-flop, and this is your delay flip-flop. Clock in is the clock input to the circuit. At the beginning, Q1, Q2, Q3 have values 0, 1, 1. Okay, respectively. So this is your synchronous counter. Which one of the given values of Q1, Q2, Q3 can never be obtained with this digital circuit? Okay, so we have to find which of the following sequence we will never get with this circuit. So we know what the next state equation of your T flip-flop is what? Q plus, or you can even write it as Qn plus 1 is equal to T XOR of Qn. And for delay flip-flop, this is for T flip-flop. And for delay flip-flop, we know that Qn plus 1 is actually equal to Qn. Okay. Now, let me write this as, this is your Q1, this is Q2, and this is Q3. So this is your first flip-flop, this is second, this is third. So let me write, what is this? Let this be T1, this be D2, this be T3. So T1 is actually equal to what? So T1 is equal to, you can see Q3 complement. Okay, because this is Q3 and this will be complemented. So Q3 complement. What about D2? So D2 is equal to Q1 and Q2 is sorry, T3 is equal to Q2. Okay. So now let us put one by one in this. So, or let me write this as, okay, let it be. So for this first flip-flop, what will be the next state equation? Qn plus 1 is equal to T1. So T1 is Q3, Q3 complement XOR with Qn. So that will be what? Basically this is the first flip-flop. So Q1. Okay. Second, for your, this is your second flip-flop is your D flip-flop. So I am going to use this next state equation. So Qn plus 1. Let me put in the subscript like this. So this is your first flip-flop. This is your second flip-flop. So this will be equal to what? This will be equal to your, sorry, here I have written Qn. So this will be actually what? This will be actually equal to your D. Okay. So D2 over here is actually equal to Q1. And for the third flip-flop, this is what? Qn plus 1 subscript 3. This will be equal to what? This will be equal to T3 plus Qn, means Q3. So T3 is actually Q2. So Q2 XOR Q3. Okay, so we have the next state equation. Now let us form one table. So the order has been given already. It is Q1, Q2, Q3. So here I will write Q1 plus 1, Q2 plus 1, Q3 plus 1. Means these are the next state equation of this, means next state of this 3 flip-flop. Okay. So now let me copy the next state equation. So you can see that I can modify this. We know one property of XOR and XNOR. X XNOR Y, this is actually equal to what? XNOR of any one of the input, or you can write it like this also. X XOR Y complement, this is actually equal to X XNOR Y. So simply I can do what? I will remove this complement and this XOR will change to XNOR. So initially this counter was initialized with value 0 1 1. So 0 1 1. Okay, 0 1 1. Let me check. Yes. So the next state equation, we know what? So this will be Q3 XNOR with Q1. So Q3 XNOR with X1, this will be 0. So Q2 plus 1, it will be actually Q1, means this one, so 0. And Q3 plus 1, Q2 XOR Q3. So 1 XOR 1, so this will be 0. At the starting of first clock edge, my initial state is going to be 0 0 0. So next state will be what? Q3 XNOR Q1. So this will be 1 0 and this will be also 1. Okay. Sorry, this will be 0 XOR 0. So this will be 0. Second clock pulse, my initial state is 1 0 0. So Q1 plus 1, it is XNOR of Q3 and Q1. So 1 XNOR 0. So that will be 0. Q2 plus 1 will be equal to Q1. So that is 1. And Q3 is XOR of this 2. So this is 0. Third initial state is 0 1 0. So next state will be what? We will have XNOR of this 2. So this is 1. Q2 plus 1 will be Q1. So this will be 0. Q3 plus 1 will be XOR of this 2. So this is also 1. So fourth initial state is 1 0 1. So next state will be Q1 plus 1 will be XNOR of this 2. So this is 1. Q2 plus 1 will be equal to Q1. So this is 1. And Q3 plus 1 will be also 1 because XOR of this 2. Fifth is 1 1 1 initial state. Next state will be Q1 plus 1 is this. So 1 XNOR 1, this is 1. Q2 plus 1 will be 1. And Q3 plus 1 will be XOR. So this is 0. Any repetition that we see? Not yet. So starting off 6th clock edge, we will have 1 1 0. So next state is XNOR of this 2. So this is 0. Q2 plus 1 will be this one. And Q3 plus 1 is XOR of this 2. So this is 1. So any repeating? Yes, you can see there is repeating. So at the 7th clock pulse, we have 0 1 1. So this is repeating now. So if you have to check, so this is 0 1 1. Next state is your 0 0 0. Then 1 0 0. Next is 0 1 0. Then we have 1 0 1. Then we have 1 1 1. From 1 1 1 we have 1 1 0. And from 1 1 0 to 0 1 1. Okay. So now let me take this to your previous page. So here it is asked which of the given values of Q1, Q2, Q3 can never be obtained with this digital circuit. So you can see 0 0 1, we are not getting anywhere. So this is your correct answer. Let us check if we are getting all the states or not. 100, you can see we have over here. 111 over here. 101. So we have over here. Okay, so all the remaining three states we have. Only option A 001 we don't have, that is your unused state. So suppose if in the same question, if it was asked that whether if we start from 001 can we go into any one of the U state. So let us check that. If suppose if I had initialized this counter with 0 sorry with 001, so what would have happened? 001. So next state will be what? So q1 plus 1 will be XOR of this 2. So XNOR, sorry. So that will be 0. Q2 plus 1 will be Q1. So that is 0. Q3 plus 1 will be Q2 XOR Q3. So that is 1. So you can see from this unused state, we are remaining in the unused state only. Okay, unused state only. So we are not going into your cyclic state. So that is why this we will not, means your counter, it will not be counting this sequence if we start from this 001 sequence. Okay. So in the next question, this is a very good conceptual question that we have over here. So what it is, a Boolean digital circuit is composed using two 4-input multiplexer M1 and M2. So these two are 4x1 multiplexer and one 2-input multiplexer M3 as shown in the figure. X0 to X7 are the input of the multiplexer M1 and M2 and could be connected to either 0 or 1. Okay. The select lines of the multiplexer are connected to Boolean variable A, B, C and C as shown. Which one of the following set of the values from x0 to x7 will realize the Boolean function A complement plus A complement dot C complement plus A B complement C? Now this is a very conceptual question. Why am I saying so? See, if nothing is given, okay, so what should be the order of A, B, C? Out of A, B, C, which is MSB, which is LSB? Can you tell me? See, whenever we have such kind of circuit, remember the multiplexer whose selection line is actually driving other multiplexers, that is your MSB. So here you can see this selection line has actually the control whether M1 will be selected or M2 will be selected. If this selection line is actually 0, so M1 will be selected. If this selection line is 1, M2 will be selected. So what is the variable attached to the selection line of M3? So this is B. So B will be your MSB. Now out of AC, you can see A and C is common to this level. So A and C, which is MSB, which is LSB? So very simple, you will be telling, sir, A is MSB, C is LSB. So order should have been like this: B, A, C. Okay, where B is MSB and C is LSB. But in the question, you can see what? That here this order has not been followed. Here it is taken that A is MSB and C is LSB. So instead of this, if this order was followed, and directly if the question would have been like this: A complement plus A complement C complement plus, this would have been written like this: B complement AC. So whatever minterms for this you would have got, okay, minterm, like suppose for this A complement you would have said 0, 1, 2, 3. For this one A complement C complement means this one will be 0 and I think this will be 1, so 2, and this will be B complement, so 0, 1, 1, so this will be 3. So here you can see if I had to write the corresponding minterm, so this will be 0, 1, 2, 3. So you would have immediately said, sir, x0, x1, x2 and x3 should be 1. But here this order has not been followed. So what to do? See over here. This has been given. A complement plus A complement C complement plus A B complement C. Okay. So what will be the corresponding min term? So for A complement, this will be, if I have to write, so see, I will show you one shortcut. So A complement, so B is don't care, C is don't care. So what all possible combination I can get? 0, 0, 0, 0, 0, 1, 0, 1, 0 and 0, 1, 1. Means the value of A is fixed, it is 0, and remaining BC I am taking all the possible combination. So this is 0, this is 1, this is 2, this is 3. Next is A complement C complement. So this I can write it as A is 0, B is don't care, C is 0. So 0, 0, 0 and 0, 1, 0. So this will be 0 and 2. And last is A B complement C. So this is 1, 0, 1. So that will be 5. So min term for this expression, it will be what? 0, 1, 2, 3 and 5. Okay, fine. So let me erase all this part. Okay, so this is the min term I got. So now we have to see basically from what possible combination of x0 to x7 will satisfy this min term. Okay. So first let us check for this one. So 0 corresponds to what? See, this is for ABC. Order is for ABC. So this is 0, 0, 0. So when we have 0, 0, 0, let us see which of the input will be coming to your output. So B is 0. B 0 means what? We will be selecting M1, and A and C is also 0, 0. That means X0 will be selected. So X0 selected, output will be X0. So for this min term to be valid, X0 should be what? X0 should be equal to 1. Next min term value is 1. So A, B, C, this value should be 0, 0, 1. So for this one, we get x0, 1. Let us see for A, B, C equal to 0, 0, 1. Which of the input will be going to your output? So you can see still B is 0. B 0 means M1 will be selected. Out of x0 to x3, which will go? So 0, 1. A value is 0, C value is 1. So A0, C1 means x1 will be selected. So x1 will go to output. So that is why x1 should be 1. Next value of ABC is what? I am taking 2. So that means 0, 1, 0. So for 0, 1, 0, let us see which input will go to output. So when B is equal to 1, okay, when B is equal to 1, that means M2 will be selected, and value of A and C is what? It is 0, 0. That means X4 will go to output. So X4 should remain 1. Next value of ABC is 3. So that is 0, 1, 1. Once again, you can see B value is 1. So when B is 1, M2 will be selected. And which from X4 to X7, which input will go to output? So A value is 0, C value is 1. So X5 will go now. X5 will go from where? It will go from input side to output. So x5 will remain 1. Next ABC value is 5. So 1, 0, 1. So when this is 1, 0, 1, once again you can see B value is 0. So when B value is 0, this is the selection line. So it will select basically M1, and which input from X0 to X3 will go? So A1, C1, that means X3 will be going to your output. So this will have to be 1. So out of x0 to x7, you can see, so if I have to write the order, so this will be x0 is 1, 1, x2 is should be 0 because we are not getting, x3 should be 1, x4 is 1, x5 is 1, x6 is 0, x7 is 0. So which sequence are we getting? Double 1, 0, triple 1, 0. Double 1, 0. So I can see this is double 1, 0, triple 1, double 0. So option C is your correct answer. So this is why I told you. Here you can see basically your MSB LSB should have been like BAC, But in this question for ABC they have asked, that is why I have done this. So this was a very good question. Okay. So with this we end this session. Thank you.